Hello and welcome to Python for Linux and DevOps Engineers. My name is Mohammed Turki, and with my colleague Mohammed Khalil, we will be your instructor throughout this course. We are excited to guide you through the powerful combination of Python, Linux, and DevOps. You might be wondering, why take this course? In today's tech landscape, there is a high demand for professionals with automation skills. Python stands out as a versatile tool that's invaluable for both Linux administration and DevOps tasks. This course aims to bridge the gap between development and operations teams, empowering you to manage systems more efficiently and effectively. So, what will you gain from this course? You will achieve proficiency in Python scripting specifically tailored for Linux administration. You will learn how to automate routine DevOps tasks, saving you time and reducing the potential for human error. We will equip you with the skills to integrate Python with powerful tools like Ansible, Docker, and Kubernetes. Plus, you will complete a capstone project that you can proudly add to your professional portfolio. Who is this course designed for? If you are a Linux system administrator, a DevOps engineer, or an IT professional interested in automation, this course is perfect for you. Even if you are simply eager to enhance your Python skills in a practical, hands-on context, you will find immense value here. Let's delve into the core objectives of this course. First, we will help you understand the fundamentals of Python programming. Then, we will teach you how to automate Linux system tasks using Python scripts. You will learn to integrate these scripts with popular DevOps tools, creating a seamless workflow. Finally, you will develop real-world applications for automation and orchestration, preparing you for practical challenges in the industry. By the end of this course, you will have a robust set of skills. You will be able to write Python scripts for various system administration tasks. You will know how to automate backups, system updates, and monitoring process. You will manage Docker containers and Kubernetes clusters using Python. Additionally, you will interact with APIs and database for DevOps automation, and importantly, you will implement best practices including security and testing. So, what specific skills will you acquire? You will gain proficiency in Python programming and develop expertise in the Linux command line. You will master automation scripting techniques and learn how to integrate DevOps tools like Ansible, Docker, and Kubernetes into your workflows. Beyond technical skills, you will enhance your problem-solving abilities and project development experience. Why is Python the preferred language for automation? Its simple and readable syntax makes it accessible. Even if you are new to programming, Python boasts extensive standard libraries and a wealth of third-party modules, enabling you to perform a wide array of tasks without reinventing the wheel. It is cross-platform compatible, so your script can run on various operating systems with minimal adjustments. Plus, Python has strong community support, providing a rich resource for troubleshooting and learning. In the realm of Linux administration, Python is a game changer. It allows you to automate routine tasks like backups and log management, freeing up your time for more strategic initiatives. You can manage system configurations and deployments efficiently, ensuring consistency across environments. Python scripts enable you to monitor system performance and health, helping you proactively address potential issues. Moreover, Python enhances traditional shell scripts with advanced logic and functionalities. Python is integral to modern DevOps practices. It can automate continuous integration and continuous deployment pipelines, streamlining the development lifecycle. Python facilitates infrastructure as code implementations, allowing you to manage your infrastructure programmatically. You can orchestrate containers and microservices effectively, making deployment and scaling more manageable. Additionally, Python enables you to interact with cloud services like AWS, Azure, and Google Cloud through their SDKs, automating cloud operations seamlessly. Looking at industry trends, the adoption of DevOps methodologies is rapidly growing. Companies are increasingly seeking efficient automation solutions to improve scalability and reliability. There is a significant demand for professionals skilled in Python and DevOps tools. By mastering these skills, you are positioning yourself at the forefront of technological advancement in system management. In this course, we will be using the latest version of Python, which offers the latest features and syntax improvements. Python 3 provides robust standard libraries for operating system interaction, networking, and much more. We will cover how to use virtual environments for dependency management, ensuring your project remains organized and conflict-free. Key packages we will explore include requests for HTTP operations, Paramiko for SSH connections, Docker for container management, and Kubernetes for orchestrating clusters. Our focus will be on Linux operating systems, specifically distributions like Ubuntu and Rocky. We will delve into command line proficiency with Bash, a crucial skill for any system administrator. You will learn to understand and manage system process and service effectively. Additionally, we will cover file system navigation and manipulation, enabling you to handle files and directories confidently. Regarding development environments, we will utilize several IDEs and text editors to suit different preferences. We will explore Visual Studio Code, PyCharm, and other editors, highlighting their features and how to optimize them for Python development. Version control is essential, so we will use Git for source code management and a platform like GitHub or GitLab for repository hosting, facilitating collaboration and code sharing. Integration with DevOps tools is a significant component of this course. We will work with Ansible for automation and configuration management, learning how to write effective playbooks. Docker will be used for containerization, and we will cover how to manage images and containers using Python scripts. Kubernetes will help us with container orchestration, teaching you how to deploy and scale applications efficiently. We will also touch on GitHub Actions for continuous integration and continuous deployment, and of course, Git as our version control system. Beyond the core tools, we will explore additional technologies that enhance your automation capabilities. We will cover databases like MySQL or PostgreSQL and MongoDB for NoSQL, teaching you how to interact with data programmatically. Cloud services are increasingly important, so we will use SDKs like PO23 for AWS, Azure SDK for Microsoft Azure, and Google Cloud SDK. This will enable you to automate tasks across various cloud platforms. Lastly, we will make extensive use of resources and documentation to support your learning. The official Python documentation is an invaluable resource for understanding language features and standard libraries. Linux man pages and guides will assist you in mastering system commands and configurations. We will also utilize documentation and tutorials for DevOps tools like Ansible, Docker, and Kubernetes. Don't underestimate the value of community forums and discussion groups. They are excellent places to seek help and share knowledge. Thank you for joining me in this journey and see you in the next lesson. Hello everyone and welcome to this lesson on Python's basic syntax and semantics. I am excited to guide you through the foundational rules that govern how Python code is written and interpreted. As Linux and DevOps engineers, having a solid understanding of Python's syntax is crucial for automation and scripting tasks. In this lesson, we will cover Python syntax basics, including indentation, comments, and line continuation. First, let's talk about indentation in Python. Unlike many other programming languages that use braces or keywords to define code blocks, Python uses indentation. This means that the way you indent your code determines how it is grouped. In this lesson, we will be using Jupyter Notebook. So here is our first example, which is a simple if statement. Notice that the print statement is intended for spaces under the if condition. This indentation tells Python that the print function is part of the if block. Let's execute this cell, and as you can see, the output is this is indented properly. Now let's remove the indentation from our example. So I will copy the if statement to this cell, and now let's remove the indentation, and I will change the statement here to be this will cause an error. Now let's run the code and let's see how Python will throw an indentation error. So let's run this cell, and as expected, we get indentation error, expected an indented block. So always remember, use constant indentation. The standard is 4 spaces per indentation level. Avoid mixing tabs and spaces to prevent errors. Now let's move to comments. Comments are essential for making your code understandable to others and to yourself when you revisit it later. For single-line comments, use the hashtag symbol. For multi-line comments, you can use triple quotes. However, keep in mind that triple quotes are actually used for multi-line strings, but when they are not assigned to a variable, they effectively act as comments. Sometimes your code might be too long for a single line. Python allows you to continue lines using a backslash for explicit line continuation. So as you can see here in this example, we defined a variable that equal to 1 plus 2 plus 3. Then we continue our lines using the backslash, then 4 plus 5 plus 6. After that, we print the total, and the output from this example will be 21. You can also implicit line continuation inside parentheses. So let's take the same example here, and let's open parentheses and close it, and we can remove the backslash, and now let's run this cell, and as you can see, the output is 21. So both methods help improve code readability without causing syntax errors. And by that, we get to the end of our lesson. Thank you for watching and see you in the next lesson. Hello and welcome to Python for Linux Admins and DevOps. In this lesson, we are diving into code structure, a fundamental concept to keep your projects clean, organized, and manageable, especially as they grow. In this lesson, we will cover the difference between scripts and modules in Python and how to make your scripts executable in Linux environment. In Python, every file you write can serve one of two primary purposes, as a script or as a module. A script is a Python file designed to be run directly. Think of scripts as a standalone piece of code that perform a specific function when executed. On the other hand, a module is also a Python file, but instead of running on its own, it's meant to be imported and used in another script. Modules help you reuse code across projects and keep your functionality neatly organized. So, why does this matter? Knowing the distinction helps you plan and structure your projects more effectively. For instance, you might write a script to automate a daily task, while a module might contain functions that multiple scripts can share. Now, let's talk about something useful for Unix Linux environments, the shebang line. This line allows your script to be executed directly by the system without explicitly calling Python. To make this happen, add the following line at the very top of your script. So let's type hashtag, then exclamation mark, then /usr /bin /env, then space Python 3. This line tells the operating system to use Python 3 to execute your code. But there is one more step to make your script truly executable. You will need to change its permission. But before changing the permission, let's add here to our first script a print message. So let's type print, then double quotations, hello world. Now let's save our file, and from the terminal, let's change the permission for script.py. So I will just type chmod +x to make the script.py executable file, then script.py. Now instead of running the script using Python script.py, I can run it with /. Now press enter, and as you can see, I managed to execute the script.py using the shebang line. This feature is especially handy for automation tasks and system-level scripts, as it simplifies execution and integrates smoothly with other shell commands. That's it for this lesson on code structure. Remember, understanding the role of scripts and modules will help you write cleaner, more organized code. And adding the shebang line is a small but powerful tweak to streamline your workflow in Linux environments. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson, variables and identifiers in Python. In this lesson, we will explore how to name variables properly and understand the importance of reserved keywords. Variables are fundamental in programming. They store data that your program can manipulate. In Python, you don't need to declare a variable's type explicitly. For example, let's define two variables here. Our first variable is age equal to 25, and name equal to double quotation Turkey. Here, age is an integer and name is a string, but we didn't have to specify that. They are automatically recognized by Python. Now let's talk about naming conventions. When naming your variables, there are some important rules and best practices to follow. Starting character. Variable names must start with a letter from A to Z, small letters or capital letters, or an underscore. The underscore user is correct. Data1 is correct. 1 data and the @name both are incorrect. For allowed characters, after the first character you can use letters, numbers, and underscores. Examples: total underscore sum, user underscore name, value 2. Variable names are case sensitive. This means my var, and my var are all different variables. Python official style guide recommends using snake underscore case for variable names. This means all letters are lowercase and words are separated by underscores. Let's see an example for that. So from here, I will define a variable user underscore name equal to single quotation admin and server underscore IP equal to single quotations 192.168.1.1. So using a snake underscore case improves readability and keeps your code consistent with Python community standards. Now let's talk about Python reserved keywords. Python has a set of reserved keywords that you cannot use as variable names. These are words that have special meaning in Python's syntax. So you can't use if, else, for, while, def, class, and return. Any attempt to use any of these as variable name will result in a syntax error. So let's see that as an example here. So I will define a variable def equal 5. And as you see here in my Visual Studio, there is a red line and it's a expected function name after def. So let's comment this out. And to see the full list of reserved keywords, you can use the keyword module. So let's type here import keyword to import the keyword module. Then I will print keyword list. Now let's execute this script. So I will type Python 3, then variables and identifiers. And as you can see, it will print a list of all reserved words like true and as assert, import in, is, with, and yield. So our conclusion for this lesson is to always ensure your variable names are meaningful and descriptive, following the naming conventions, not using any reserved keywords. By adhering to these guidelines, you will write cleaner, more maintainable Python code. Thank you for joining me in this lesson on variables and identifiers. Happy coding and see you in the next lesson. Hello and welcome to a new lesson where we will dive into an essential aspect of Python programming, understanding statements and expressions. By the end of this lesson, you will have a clear understanding of how they differ and how to use them effectively in your code. Let's start with expressions. In Python, an expression is any piece of code that produces a value. For instance, when you write 2 plus 3, it evaluates to 5. Expressions are valuable because they can be part of more complex calculations or logic. Now, let's look at statements. A statement is an instruction that performs an action. For example, an if statement or a for loop directs Python to perform specific tasks based on conditions or to repeat certain actions. In other words, statements control the flow of our code. You can technically write multiple statements on a single line using a semicolon. For example, here we write x equal 5, semicolon, y equal 10, semicolon, print x plus y. However, this is generally not recommended because it makes the code harder to read. So a better approach is to break each statement onto its own line. So let's break each statement here, but first let me comment this line. So we will do x equal 5, y equal 10, then print x plus y. This structure is much clearer and improves readability, which is essential for writing clean, maintainable code. To recap, expressions are parts of code that produce values, and statements direct actions. Keeping your code readable by separating statements across lines is a best practice that will benefit you as you write more complex code. Thank you for watching this lesson and see you in the next one. Hello everyone and welcome to this lesson on practical examples in Python programming. In this lesson, we will explore two foundational examples that demonstrate basic syntax and the importance of proper indentation in Python. So, let's start by writing the classic Hello World program. This simple program is a great way to get familiar with Python's syntax. So here in Visual Studio, let's type print, then hello world. Now let's run the code. So from the terminal, I will type Python 3, then example1.py. And of course, I didn't get any output because I didn't save the file. So let's save our file. Now let's execute again Python 3 example_1.py. As you can see, when we run this code, it prints hello world. The print function outputs the text inside the parentheses to the console. It's one of the most basic and essential functions in Python. Now let's demonstrate the importance of proper indentation in Python using an if statement. So let's type if true, then print condition is true, another print, and this time we will print this is inside the if block. Now we will print outside the if block. So I will print here, and this time the statement is this is outside the if block. Now let's run the code. So from the terminal, I will type Python 3, then the name of our file example2.py. Now press enter, and we can see the output from each print function. So what's happening here? The first two print statements are indented under the if true condition. Since the condition is true, these two lines execute. The last print statement is not indented under the if block. This means it executes regardless of the if condition. Proper indentation is crucial in Python because it defines the scope of code blocks like loops, functions, and conditional statements. That's all for this lesson. We have covered how to write a simple Hello World program and explored how indentation affects code execution in Python. Understanding these basics is essential as you continue your programming journey. Thank you for joining me and happy coding. Hello and welcome to a new lesson on conditional statements in Python. In this lesson, we will explore how to direct the flow of a Python program by making decisions based on conditions. By the end of this lesson, you will understand how to use if, else-if, and else statements to make your programs dynamic and responsive. Let's get started. First off, what exactly are conditional statements? In Python, conditional statements are tools that allow a program to execute certain pieces of code based on whether a condition is true or false. Think of them as decision makers in your code. They enable your scripts to perform different actions depending on the input or the situation at hand, making your programs more dynamic and interactive. Before we dive into conditional statements, it's essential to understand Boolean expressions and comparison operators. In Python, there are two Boolean values, true and false. These are the outcomes of conditions and are the backbone of decisions making in programming. For the comparison operators, we have equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. Then the logical operators we have AND, which returns true if both conditions are true. We have OR, which returns true if at least one condition is true. Then we have NOT, inverts the Boolean value of a condition. Let's understand together from our short examples here. So first we will begin by using the comparison operators. So we have two variables here. The first variable is A and the second variable is B. We defined variable A as 10 and variable B as 20. When we do print A equal B, this is of course false. Print A not equal B, true. Print A less than B, which is also true. We will see another example using the logical operators. Is underscore admin equal true? Is underscore logged underscore n equal false? Now we have if statement here. So if is underscore admin and is underscore logged in, print access granted, else print access denied. So this if condition here is false because both logical operators are not true. So when we execute this part of code, it will print access denied. Now let's look at the basic if statement, which is the foundation of conditional logic in Python. Suppose we want to monitor disk usage and issue a warning if it exceeds 80%. Here is how we might do it. So in this example, if disk usage is greater than 80%, the message inside the print function will be displayed. Often, you will need to check multiple conditions. This is where else if and else come into play. For example, let's check the status code of a web request. So here, in this example, the program checks if status code is 200 and prints OK if it is. If not, it checks if it's 404 and prints not found. If neither condition is met, it defaults to printing error. Conditional statements can also be nested within each other to handle more complex logic. Suppose we want to grant access to an admin panel only if the user is logged in and is an admin. In this example, the program first checks if user underscore logged underscore in is true. If so, it then checks if user underscore role equals admin. Only if both conditions are true does it print the access message. Now that we have covered the basics of conditional statements, let's apply what we have learned with some practical examples that you can run directly in Python. First up, let's create a simple program that checks whether a number entered by the user is even or odd. So let's type number equal int, then input to take input from the user. Then we will provide a message for the user enter an integer. Then let's type if number modulus 2 equal 0, print number is even, else it will print number is odd. So let's explain this script. At line 1, we prompt the user to enter an integer using the input function and converted it to an integer with int function. At line 3, we use an if statement to check if the remainder of number divided by 2 is 0 using the modular operator percentage. If it is, the number is even. Line 4, if the condition is true, we print that the number is even. Line 5, the else clause handles the case where the number is not even, meaning it's odd, and we print that. Now let's validate our work. So I will execute this script using Python 3, then the name of our script, which is conditions_statements.py. Now press enter. And as you see, it asks the user to enter an integer. Let's enter, or let's type number 8. As you see, the number is even. Now let's execute the script again, and this time I will type 9. And as you see, number is odd. So this simple program demonstrates how conditional statements can be used to make decisions based on user input. So our conclusion for this lesson is that conditional statements are a fundamental aspect of programming in Python. They enable your programs to make decisions and respond differently based on varying conditions, making your scripts more robust and adaptable. Thank you for joining me in this lesson on conditional statements, and see you in the next lesson. Hello and welcome to a new lesson on looping constructs in Python. In this lesson, we will explore the for and while loops, two essential tools in programming that make our code more efficient by automating repetitive tasks. Let's dive in and see how they work and where we can use them. The objective of this lesson is to understand the fundamentals of for and while loops. We will cover their syntax, usage, and go over some practical examples to see these loops in action. Why do we need loops? Loops help us automate repetitive tasks by reducing redundancy in our code. This way, we can execute code multiple times without having to rewrite it, making our script simpler and easier to maintain. Python provides two main types of loops. First, we have for loops, which iterate over sequences like strings and ranges. Second, we have while loops, which continue running as long as a certain condition is true. This is the basic syntax for a for loop in Python. Here is what it looks like. For variable in sequence, then the code block to execute. The for loop goes through each item in the sequence. The variable takes the value of each item, and then the code block under the loop is executed for each item in the sequence. In this example, we are iterating over a string using a for loop. Each letter in the word Python is printed on a new line. This example shows how for loops can easily process each character in a string one at a time. The range function is another powerful tool for loops. It generates a sequence of numbers. Here are some common ways to use it. Range stop generates numbers from 0 up to 1 less than stop. Range start, stop generates numbers from start to stop minus 1. And range start, stop, step generates numbers from start to stop minus 1, incrementing by step. Here is a quick example. For I in range 5, print I. So this code will print the numbers from 0 to 4. Next, let's look at while loops. Here is the syntax. A while loop checks the condition before each iteration. If the condition is true, the code block executes. The loop continues until the condition becomes false. Here is an example of while loop. We define count equal to 0, then while count less than 3, print count is then the value of count, and count plus equal 1. This loop will print the count from 0 to 2. Notice that we increment count to avoid an infinite loop, so the condition eventually becomes false. With while loops, there is always a risk of creating an infinite loop. To avoid this, ensure the loop's condition will eventually become false by updating the variables in the condition within the loop. Now let's talk about control statements in loops. Python gives us additional control with break and continue statements. Break stops the loop immediately, which can be useful if we want to exit the loop when a specific condition is met. Continue skips the current iteration and moves to the next, allowing us to skip over certain values. Here is an example using break. So this loop will stop as soon as num reaches 5. Break exits the loop, so the number 1 through 4 are printed and the loop doesn't go any further. Now let's see continue in action. Here, the continue statement will skip the number 3 and print all other numbers from 1 to 5. This is helpful if we want to avoid specific values in our loop. To make the most of loops, follow these best practices. Use proper indentation to define code blocks in Python. Choose meaningful variable names for readability. Set clear exit conditions, especially in while loops, to avoid infinite loops. Finally, use consistent formatting to make code easier to read and maintain. In summary, loops are essential tools for automating repetitive tasks and reducing code redundancy. Both for and while loops have their place in Python. Remember to use break and continue for finer control over loop execution. Thank you for joining me in this lesson on looping constructs in Python. Now that you understand for and while loops, you will be able to handle repetitive tasks more efficiently in your code. Thank you for watching and see you in next lesson. Welcome back. In this lesson, we are going to apply our knowledge of loops by working through some practical examples. I will explain how the loops help us solve real-world problems efficiently. Let's get started with our first example, calculating the sum of numbers from 1 to 5. To begin, we will start by defining a variable to hold our sum total. I will type total equal 0. Setting total to 0 will give us a starting point, allowing us to add numbers to it as we go. Now, let's set up a for loop to iterate through each number from 1 to 5. I will type for num in range 1 to 6. The range function here generates numbers from 1 to 5. Each time the loop runs, num will take on the next number in that range. Inside the loop, we will add each number to total. I will type total plus equal num. So this line takes the current value of total and adds num to it, updating total with the new sum. After the loop, let's print the result. I will type print total sum and the total value. This line will display the final value of total after the loop has added up all the numbers. Now let's execute this from here, from the terminal using Python 3, then the name of our file, which is for_and_while_loops.py. As you see from the output, we get total sum 15. This tells us that our loop successfully calculated the sum of numbers from 1 to 5. Each time the loop ran, it took the next number in the range and added it to our total variable. Great, now let me clear the terminal here. Now let's move to our second example where we will use a loop to calculate the factorial of a number. This will help you see how loops work for multiplying sequences of numbers. But before starting with second example, let me comment the first example here. So I will add triple single quotations. And now we are ready to go with our second example. To start, let's define a variable to store the number we want the factorial of. I will type number equal 5. We are setting this to 5 as an example, but you could change it to any positive integer. Next, let's initialize a factorial variable to store our result. I will type factorial equal 1. Setting factorial to 1 is important because in multiplication, starting with 1 won't change the outcome, and we will be multiplying it by each number in the loop. Now we will set up a for loop that goes through each number from 1 up to and including number. So I will type for I in range 1 and number value plus 1. This range starts at 1 and goes up to number, which is 5 in our example. Inside the loop, we will multiply factorial by the current number I. So I will type factorial multiply equal I. This line multiplies factorial by I each time the loop runs, updating factorial with the new product. Finally, let's print the result. I will type print factorial of number value is factorial value. So let's use the print function, if then double quotations, and between the double quotations, factorial of number value is factorial value. So this will display the factorial of 5 after the loop complete. Now let's execute but before the execution, let me save the code here. And now let's execute this code using Python 3. As you see, the output shows factorial of 5 is 120. So the loop successfully multiplied each number from 1 to 5, giving us the correct factorial value. Great job following along. We have used for loops to tackle practical problems, calculating a sum and finding a factorial. These examples show how loops can help you automate repetitive tasks in Python, making your code efficient and easy to understand. With these skills, you are now better equipped to to use loops in real-world scenarios. Keep practicing, and I will see you in the next lesson. Hello and welcome to this lesson on loop control statements in Python. In this lesson, we are going to learn about how to control the execution flow within loops using break, continue, and pause. By the end of this lesson, you will know how to apply these statements effectively in your code. So, let's get started. In this lesson, we are focusing on three key loop control statements in Python: break, continue, and pause. These statements allow you to modify the behavior of loops, giving you more control over their execution. Let's start with break. The break statement is used to exit a loop before it has completed all its iterations. This can be especially useful when you need to stop processing once a specific condition is met. Let's look at the example code. As soon as num equal to 5, the break statement triggers and the loop stops. Only the numbers 1 through 4 are printed. Next, we have the continue statement. This is used to skip the current iteration and move to the next one. It's ideal for ignoring certain conditions while allowing the loop to keep running. In our example, when num equal 3, the continue statement is executed. So 3 is skipped and the rest of the numbers are printed. Now let's talk about the pause statement. This statement does nothing when executed. It's essentially a placeholder that allows you to write syntactically correct code when you don't want any operation to occur. In our example, when num equal to pause is executed, the loop continues normally and all numbers are printed. Loop control statements are incredibly useful in specific scenarios. Use break to exit loops early when a condition is met, such as finding the first match in a dataset. Employ continue when you want to skip specific iterations, like ignoring invalid inputs. Finally, use pause as a placeholder during development or when you need a block of code without any operation. To wrap up, we have covered how break, continue, and pause can help you control the execution flow within loops. These statements allow you to make your code more flexible, adaptable, and easier to read. Practice using these loop control statements in different coding scenarios to understand their benefits fully. Thank you for watching and see you in next lesson. Hello and welcome. In this lesson, we will dive into some practical examples using the break, continue, and pause statements in Python. These examples will help you understand how to control loop execution flow in real-world scenarios. Let's get started with our first example. First, let's define a list of numbers. We will cover lists in more detail in future lessons, but for now, let's just define a list. So, I will type number equal, then a list of numbers. This list contains several integers that we will loop through. Now we will create a for loop that goes through each number in the list. So I will type for num in numbers. This line means we are iterating through each element in numbers, and num will represent the current number. Inside the loop, we want to check if num equal 5. So I will type if num equal 5. This conditional checks if the current number is 5. If num is 5, we will print a message and break out of the loop. So I will type print found 5 exiting loop, then break. So this will stop the loop as soon as 5 is found. Finally, I will add a line to print the current number during each iterations just before the condition. So I will type print checking number num. Now we are ready to execute our Python code. So I will type Python 3, then the name of the file, which is loop control statements. As you can see, when we executed the code, it printed each number until it finds 5 and then stop the loop. So it didn't print 19 nor 25, which means that the break statement is worked as expected. Next, let's modify our example to illustrate the continuous statement. We will start with a new list of numbers. So let's modify this one to be numbers equal, then a list from 1 to 10. Again, we will cover more about lists in future lessons. Now we will write a for loop that iterates through the list. So we already have this for num in numbers. Inside the loop, we want to skip any number that is divisible by 3. So I will modify the if statement here to be if num modulus 3 equal 0. So this condition checks if num divided by 3 has no remainder, meaning it is divisible by 3. Next, I will remove this one, and I will replace the break with continue. The continue statement tells Python to skip the current iteration and move on to the next number. Now outside the condition, we will print the current number. So I will replace this print with print number, then num. Now let's execute our Python code from the terminal. As you see, when we executed the code, it printed all the numbers except those that are divisible by 3. For our last example, let's see how pass works as a placeholder in loops. I will define a list again by typing numbers, then a list from 1 to 5. Now let's create a for loop. So I will type for num in numbers. So this loop will iterate over each item in numbers. Let's add a condition to use pass when num equals 3. So I will type if num equal 3. Inside this condition, I will type pass. This statement does nothing. It is just a placeholder to keep the loop struct intact. After the condition, we will add a print statement to see the numbers being processed. So I will type else, then the print statement processing number, then the number. Now let's execute this code. And as you see, the number 3 is still part of the loop, but nothing happens when it is processed. It acts as if no operation was executed for 3. And this is the purpose of pass control statement. Now I can say great job. We have walked through practical examples using break, continue, and pass in Python. These statements give you more control over how loops execute, making your code more efficient and adaptable. Keep practicing these concepts to get a better feel for when and how to use them in your own code. Thank you for watching, and see you in next lesson. Hello and welcome to a new lesson on Python's core data structures: lists, tuples, sets, and dictionaries. By the end of this lesson, you will be familiar with these essential structures and know how to use them for efficient data storage and manipulation. Let's begin with lists, one of the most flexible data structures in Python. To create a list, type servers equal web1, web2, db1. This defines a list of server names. To access an element, use the index. For example, first server equal server 0 will retrieve the first item in the list, which is web 1. You can modify a list easily. To add an item, type server.append cache 1. This appends cache 1 to the end of the list. To remove an item, use servers.remove db1, which will remove db1 from the list. Slice operations are also possible. For instance, web_servers equal servers 2.2 will give you the first two elements of the list. Lists come with several built-in methods like append, insert, remove, pop, sort, and reverse. Next, we have tuples, which are similar to lists but immutable. To create a tuple, type config equal localhost, 8080. This tuple contains two elements, a host name and a port number. One key characteristic of tuples is that they cannot be modified after creation, which ensures data integrity. Accessing elements in a tuple is straightforward, similar to lists. For example, host equal config 0 retrieves the first element, localhost. Moving on to sets. These are used to store unique elements and are great for removing duplicates. To create a set, type unique users equal Alice, Bob, Charlie. Sets don't maintain order and only contain unique elements. To add an element to the set, type unique_users.add David. This will add David to the set if it is not already present. Sets come with powerful operations like union, intersection, and difference. To find the union of two sets, use set1.union set2, for example. To find common elements, use set1 intersection set2, and for elements present in one set but not in the other, use set1.difference set2. Finally, let's discuss dictionaries, which store data as key value pairs. To create a dictionary, type user_roles equal Alice admin, Bob user. Here, Alice is a key with a value of admin and Bob is a key with a value of user. To access a value, type role equal user_roles Alice. This retrieves the value associated with the key Alice. You can also add or modify entries. For example, user_roles Charlie equal moderator adds a new entry or update an existing one. Dictionaries come with helpful methods like keys, values, items, get, and pop for various operations. You now have a solid understanding of Python's code, data structures, lists, tuples, sets, and dictionaries. These structures will help you store and manipulate data efficiently in your scripts and code. Practice using them to become more confident, and I will see you in the next lesson. Hello and welcome to our practical lesson on lists, tuples, sets, and dictionaries. Let's start with lists. So first, let's create a list of server names. So I will type servers equal a list of web1, web2, and db1. So this defines a list containing 3 strings representing server names. Now let's access the first element in the list. So I will type first_server equal servers 0. The index 0 retrieves the first item in the list. Then I will print it using print first server and the value of first server. So this should display web1. Next, let's add a new server to the list. To do so, I will type servers.append, then our new server I want to add, which is cache1. The append method adds cache1 to the end of the list. Now let's print the updated list with print function, then list after adding cache1, then our list, which is servers. Now we will remove an item. So I will type servers.remove, and let's remove db1 from the list. So the remove method deletes db1 from the list. Now let's print the list again with print function. So I will just type print list after removing db1, then the server or the servers list. Finally, let's slice the list to get the first two servers. So I will type web_servers equal our list, then from or 2 dots and 2, and this will print the first two servers. Now I will use the print function to print the first two servers from the value of web servers. Okay, now let's execute our code in the terminal. So I will type Python 3, then the name of the file, and enter. And as you can see, as expected, first server is web1. List after adding cache1. Here is cache1 appended to the end of the list. And the list after removing db1. Here is the list without db1. The first two servers, web1 and web2. Now let's move to our second example, but first I will comment the first example here. Now let's move on to tuples. I will create a tuple with a host name and port. So I will type config equal, then local host and 8080. This tuple stores two elements, the string localhost and the integer 8080. To access the elements, I will type host equal config 0 and port equal config 1. Let's print these values using print function. So to print the host, I will type print host and the host value, and the same with port. So I will type print port and the port value. Tuples are immutable, which means we can't modify their elements. For example, if we try to change config 0 to be 127.0.0.1, it will raise an error. This immutability is important for data integrity. Okay, now let's execute our code. And of course, I didn't get any output because I didn't save the file. So let me save the file and let's execute the code again. And as you can see, host, localhost, port 8080. Now let me also comment the second example code. Now let's create a set to store unique usernames. So I will type unique users, then I will define the set. So we have a set here of unique users, Alice, Bob, Charlie, and this set automatically removes duplicate entries if there are any. To add a new user, I will type unique_users.add David. The add method ensures David is included in the set. Now let's print the updated set with print function. So I will print the string set after adding David, then we will print the unique users set. Now let's perform some set operations. I will create two sets, set 1 and set 2. So set 1 will have the unique users Alice, Bob, David, and set 2 will have Charlie, David, and Eve. Now to find the union of set 1 and set 2, I will type all underscore users set 1 union set 2. Now let's print this union using the print function. So I will write print union of set 1 and set 2 all users. To find the intersection, I will type common underscore users equal to set1 dot intersection set2 and print it with print intersection of set1 and set2, then the value of common users. Lastly, to find the difference, I will type def underscore users equal set1 dot difference set2. And again, I will print it with the print function. So let me type print difference between set1 and set2 and the value of def users. Now I will save my changes to the code and let's execute it from the terminal. And as you can see, the set after adding David, so we have David here. The union of set1 and set2, David, Alice, Eve, Bob, Charlie. The intersection of set1 and set2, David. Difference between set1 and set2, Alice and Bob. Now let me comment this code also. Finally, let's work with dictionaries. I will start by creating a dictionary with user roles. So I will define a user underscore roles dictionary with Alice as a key and admin its value, Bob as a key, and user its value. To access a value, I will type role equal user underscore roles, then the key Alice. Now let's print the role here using the print function. So I will type print Alice role and the role value. Now let's add a new entry. I will type user underscore roles and I will add a new user Charlie with the value moderator. Now let's print the dictionary after adding the new entry. So I will type print dictionary after adding Charlie, then the value of dictionary user roles. To modify an existing entry, I will type user underscore roles, then Bob, to change the value for Bob from user to editor. Now let's print the dictionary after modifying Bob using the print function. Dictionary after modifying Bob's role, then we will print the dictionary. Finally, let's use some dictionary methods. I will type keys equal user roles underscore keys and values equal user underscore roles values. Let's also type items equal user underscore roles items. And let's print them with print keys to get the keys values and print values to get the values. Finally, print items to get the items. Now let me execute our code. And as you see, Alice role admin, dictionary after adding Charlie. Here is Charlie added to the dictionary with the value moderator. Dictionary after modifying Bob. So here Bob value become editor. And here is the key. It printed the dictionary keys Alice, Bob, and Charlie. And values printed the dictionary values admin, editor, moderator. And the dictionary items, it printed both the key and the value of each item in the dictionary. You have now seen practical examples of how to use lists tuples, sets, and dictionaries in Python. These data structures are powerful tools for storing and manipulating data efficiently. Keep practicing these examples to become more comfortable using them in your projects. Thank you for watching and see you in next lesson. Hello and welcome to a new lesson on list comprehensions and generator expressions. In this lesson, we will learn concise and efficient ways to create and manipulate lists and generators in Python. Our objective for this lesson is to understand how to use list comprehensions and generator expressions to write more concise and efficient code. This will help us create and manipulate lists and generators effectively. Let's start with list comprehensions. The syntax for a list comprehension is expression for item in iterable if condition. This allows you to generate a new list by applying an expression to each item in an iterable, optionally including a condition. Here are some examples. The square numbers equal x multiply 2 for x in range 10. So this creates a list of squares for numbers from 0 to 9. The even numbers equal x for x in range 10 if x modulus 2 equal 0. This generates a list of even numbers between 0 and 9. So the benefits of using list comprehensions include writing more concise and readable code, often achieving faster execution compared to equivalent loops. Next, we will look at generator expressions. The syntax is similar to list comprehensions but uses parentheses. As you see here, the expression for item in iterable if condition between parentheses. So this generator expressions produce item one at a time and are useful for large datasets. For example, large dataset equal process line for line in big file. This creates a generator that processes each line from a big file on the fly without loading the entire file into memory. The benefits of generator expressions are they are memory efficient since they generate items on the fly. They are suitable for working with large datasets where loading all data at once is impractical. Now let's look at some practical examples. So here we have our file processing example. So error underscore lines equal to line for line in log file if error in line. So this exacts all lines containing the word error from a log file. Another practical example about data transformation. So here we have user underscore IDs equal to user.id for user in users if user.active. So this creates a list of IDs for all active users. In summary, list comprehensions and generator expressions are powerful tools in Python that help you write cleaner and more efficient code. By measuring them, you will be able to handle data processing tasks more effectively, especially when dealing with large datasets. Thank you for joining me in this lesson and see you in the next one. Hello and welcome to the practical exercises for list comprehensions and generator expressions. In this lesson, we will apply what we have learned to solve real-world problems using concise and efficient Python code. Let's begin by generating a list of squared even numbers between 1 and 20. We will use list comprehension to achieve this concisely. First, we will define a variable called square underscore evens. Now let's open a square bracket to start our list comprehension. Our expression is x star star 2, which means we are squaring each number x. Next, we add for x in range 1 to 21 to iterate through numbers from 1 to 20. Now let's include the condition if x modulus 2 equals 0 to select only even numbers. Finally, don't forget to close the square brackets to complete the list comprehension. Now let's print square evens to see the result. So I will use the print function and I will print the value of squared evens. Now from the terminal, let me execute our code using Python 3. Then the name of our file list comprehensions and generator expressions.py. And as you see from the output, we have a list of squared even numbers between 1 and 20. Now let's move to our second exercise for this lesson, but first let me comment the first example here. And now in our second exercise, we will create a generator that yields lines containing a specific keyword from a log file. And here is our log file that we will use, logfile.txt. It has some content with different log levels like info, debug, error, and warning. So first, let's open our log file. So I will type here log_file, and I will use open function to open this file. Then I will provide the file name, which is logfile.txt. Then I want to read this file, so I will type here R for read. Now let's define a keyword variable, and the value for this variable will be error, all in capital letters. Now let's define a generator called keyword_lines. Let's open parentheses to start the generator expression, as we learned in our theoretical lesson. Our expression is line strip, which will remove any leading or trailing white space from each line. Now let's add for line in log_file to iterate over each line in the file. After that, let's include the condition if keyword in line to filter lines that contain the keyword. So here I will type if keyword in line. Now let's iterate over keyword_lines to process each matching line. So let's type for line in keyword_lines. Then I will use the print function to print the line. So this print function will print out all lines from log files that contain the keyword error. Finally, don't forget to close the log file. So I will type log_file. Then I will use the close function to close the file. Now from the terminal, let's execute our code. And as you see, we have all lines from logfile.txt that contains the keyword error. So in this lesson, we have put into practice the use of list comprehensions and generator expressions to write efficient and readable Python code. By generating a list of squared even numbers and creating a generator to filter lines from a log file, we have demonstrated how these constructs can simplify data processing tasks. Thank you for participating in these exercises. Keep practicing, and you will continue to enhance your coding skills with Python's powerful features. Thank you for watching this lesson, and see you in the next one. Hello and welcome to a new lesson on working with collections and iterables. In this lesson, we will master techniques for handling various iterable objects and utilizing functional programming tools in Python. Our objective for this lesson is to understand and master techniques for handling various iterable objects. We will also delve into functional programming tools that make working with collections more efficient and expressive. Let's begin by defining two fundamental concepts. Iterable, which is an object capable of returning its members one at a time. Examples include lists, tuples, and strings. Then we have iterator, which is an object representing a stream of data. It allows you to access elements sequentially using the next function. In Python, you can obtain an iterator from an iterable using the iter function. You can then traverse the elements using next function. The map function applies a specified function to every item of an iterable. Then we have the built-in function filter function. So the filter function filters items out of an iterable based on a function that returns true or false. We also have the reduce function, which applies a rolling computation to sequential pairs of values. It is part of the functools module. Let's talk about Lambda function. Lambda functions are small anonymous functions defined using the Lambda keyword. They are useful for short functions that are used only once. Here is how you can define a simple addition function using Lambda. Add equal to Lambda function x and y, two dots, then the addition of x plus y. The iter tools module offers a collection of tools for handling iterators. Some useful functions include chain function, which combines multiple iterables into one long iterable. Cycle function, which repeats an iterable indefinitely. iSlice, which slices an iterable similar to slicing a list. Group by, which groups items based on a key function. Using chain function, you can combine multiple lists into one sequence. Like here, first we import the chain function from the iter tools module, and we will define a value all underscore items. Then we will use the chain function to combine list 1, list 2, and list 3. So this is useful when you need to process several collections in a single loop. Thank you for watching this lesson, and see you in the next lesson where we will practice on working with collections and iterables. Hello and welcome to our practical exercises for working with collections and iterables. In this lesson, we will apply the concepts we have learned by working through two exercises that utilize map and iter tools group by function. Let's start by converting a list of strings to uppercase using the map function. So first, we will define our list of strings. So let's call it words. So I will define the word or the words list here to be apple, banana, and cherry. Now we will use the map function to apply the string.upper method to each word in the list. So I will define a new variable here, uppercase underscore words equal to map function, then str.upper, then the words list. Since map function returns an iterator in Python 3, we will convert the result to a list to see all the items at once. So I will define a new list here with the name uppercase underscore words, and it will equal to list of uppercases underscore words. Finally, let's print the uppercase underscore words list using the print function. Now let's execute this code using Python 3 then our file working with collections and iterables.py. And as you can see, the output is the list of words converted to uppercase. Okay, now let me comment this part of code here for the first example. Now to our second example, which we will use itertools.groupby to group log entries by date. So first, let's import the groupby function from the itertools module and assume we have a list of log entries called logs. Each entry is a tuple containing the date and the log message. So here we have the logs tuple and we have the date and the log message. Before using groupby, we need to sort the logs list by date because groupby groups consecutive items with the same key. So I will type logs.sort key equal lambda x of 0. Now we will use groupby to group the log entries by date. So let's type grouped_logs groupby function, then logs and key equal lambda x and x of 0. Now let's iterate over the groups and print out the date and the corresponding log entries. So I will type for date and the group in group logs. Then first I will print the date using the print function. Then another for loop for log in group. Let's print the log. Now let's execute our code. And as you see, the output from this code will display the log entries grouped by their dates. So in our practical examples in this lesson, we have applied functional programming tools to handle collections and iterable efficiently. And by that, we get to the end of our lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. In this lesson, we will dive into functions in Python. So, what are functions? Simply put, functions are blocks of reusable code that allows us to perform specific tasks or calculations without rewriting code every time we need it. By using functions, we can create organized, modular, and easy to maintain code. We will start by learning the basics, including how to define functions and how to use parameters and return values to customize their behavior. Let's start with the basics of defining a function in Python. Here, we have a simple function called greet. Notice the def keyword, which is how we tell Python we are defining a function. The function name here is greet, and we use empty parentheses because this function doesn't need any extra information to run. Inside the function, we have a return statement that sends back the string hello world. So when we call this function greet and using the print to print the function return, the expected output is hello world. Now let's make our function a bit more interesting by adding a parameter. In this example, we are modifying greet to take a parameter called name. This parameter allows us to pass in a specific name each time we call the function, making the greeting personalized. Inside the function, we use an if string to combine hello with the provided name. If we call greet_user with the name Alice, the output will be hello Alice. Parameters like name help us make functions that can adapt based on the input we provide, adding flexibility to our code. Let's talk about return values. Return values allows us to send data back from a function to the part of the code that called it. Here is an example. we have a function called add that takes two parameters, a and b. Inside this function, it calculates the sum of a and b and returns the result. So if we call add with 5 and 3, the function will return 8. By storing this returned value in a variable like result, we can use it later in our program to print it out directly. Return values make functions more powerful by letting us get specific results and use them in different parts of our code. Let's quickly recap what we have covered. Functions are essential tools in Python that help us create reusable, organized, and efficient code. We learned how to define functions, use parameters to customize their behavior, and use return values to send data back to the caller. By practicing these techniques, you will be well on your way to writing clean and modular code. That's it for this lesson. Keep practicing and you will soon see the power and flexibility functions bring to your Python projects. Thank you for watching and see you in the next lesson. Hi everyone. In this lab exercise, we will create a function to convert temperatures from Celsius to Fahrenheit. This will help us practice defining functions using parameters and returning values. Let's get started by writing our function definition. First, let's start by defining the function. We will use the def keyword, followed by the function name Celsius _ to _ Fahrenheit. And inside the parentheses, we will add one parameter, which is Celsius. Celsius here will be the temperature we are converting. So here, def tells Python that we are defining a function. The function name is Celsius _ to _ Fahrenheit, which describes what the function does. Inside the parentheses, we have Celsius as our parameter, which is the temperature input in Celsius that we want to convert. Now let's write the formula to convert Celsius to Fahrenheit. We will create a variable called Fahrenheit. Now we will use the formula Celsius multiply 9 divided by 5 plus 32. This formula converts the Celsius temperature to Fahrenheit. So we created a variable Fahrenheit to store the result of our conversion. The formula Celsius multiply 9 divided by 5 plus 32 is a standard way to convert Celsius to Fahrenheit. So this line will take the Celsius input, multiply it by 9, divide by 5, then add 32 to get the Fahrenheit temperature. Next, let's return the Fahrenheit value from the function. This way, when we call the function, it will give us the converted temperature back as a result. So let's type here return, then Fahrenheit. So here we use the return statement to send the value of Fahrenheit back to the place where the function was called. This means we can store this result in a variable or print it directly. Now let's test our function to make sure it's working. We will call Celsius to Fahrenheit with a few different values and print the results to see if the conversions are correct. So the first test will convert 0 Celsius to Fahrenheit. The second test will convert 100 Celsius to Fahrenheit, and the last test will convert -40 Celsius to Fahrenheit. To test our code, I will execute lab1.py from the terminal, and as you see, it printed out the conversion from Celsius to Fahrenheit for each test. That's great. Our function works as expected. We have successfully created a function that takes a Celsius temperature as input and returns the Fahrenheit equivalent. This exercise covered how to define a function, use parameters, apply a formula, and return a result. Well done, and see you in the next lesson. Hello everyone. In this lesson, we will cover two useful techniques to make Python functions more flexible: default arguments and variable length arguments. First, we will learn about setting default values for function parameters, and then we will explore how to handle varying numbers of arguments using *args and *kw args. Let's get started. Let's start with default arguments. A default argument allows us to define a default value for a parameter. Here we have a function called greet that takes one parameter, name, but notice that name is set to guest by default. This means if we call greet without passing any name, it will automatically use guest as the default. As you see here in our examples, if we call greet without any arguments, it will return hello guest. But if we call greet Alice, it will use the name we provided and return hello Alice. Default arguments are helpful when we want to provide optional parameters for a function. Now let's move on to variable length arguments. The first type is called *args, which allows us to pass a variable number of non-keyword arguments to a function. In this example, we have defined a function called calculate_sum with *args as its parameter. The *args notation allows us to pass any number of arguments, and they will be captured as a tuple. Inside the function, we simply use the sum function to add up all the values in args. So if we call calculate sum 10, 20, and 30, it will return 60, which is the sum of these three values. This makes our function more flexible as it can accept any number of numbers to sum up. Now let's look at *kw_args, which is another type of variable length argument. *kw_args allows us to pass a variable number of keyword arguments to a function, meaning arguments with both names and values. Here we have a function called describe_server, which takes *kw_args as its parameter. Inside the function, we loop through each key and value pair in the kw_args dictionary and print them. So if we call describe_server, name equal server1, status equal running, the function will print out name server1 and status running. Using *kw_args is very useful when we want our function to handle multiple named parameters that we might not know in advance. To wrap things up, we have learned about default arguments, *args and *kw_args. Default arguments let us set optional values for function parameters. *args allows our function to accept a flexible number of non-keyword arguments, while *kw_args let it handle a flexible number of keyword arguments. These techniques make our functions more versatile and able to adapt to different inputs. Great job, everyone. Keep practicing and you will get comfortable with these handy features in no time. Thank you for watching and see you in the next lesson. Hello everyone. In this lab exercise, we are going to create a function that calculates the average of a variable number of arguments. This will give us more practice with variable length arguments in Python, specifically using asterisk args to handle multiple values. So let's dive in. We will start by defining our function. Let's call it calculate_average. Since we don't know how many arguments might be passed, we will use asterisk args as our parameter. This will allow us to handle any number of values. So here the def is a keyword that tells Python we are defining a function, and the function name is calculate_average, which tells us this function will calculate an average. We use asterisk args to allow a variable number of arguments so we can pass in as many numbers as we want. Before calculating the average, let's add a check to make sure that at least one number was provided. So let's add if length of args equal 0, return none. We are using an if statement to check the length of args using len args. If it is 0, that means no numbers were provided. In that case, we will simply return none. This prevents our function from trying to calculate an average with no data. Now let's calculate the average. We will use the sum function to add up all the numbers in asterisk args and then divide by the total number of arguments using len args. So here we are creating a variable average to store our result. The sum args part adds up all the numbers in asterisk args, and then we divide by the number of arguments using len of args. So this line gives us the average of all the numbers passed to the function. Finally, let's return the average value from the function so we can see the result when we call it. So I will just type return, then average. As we learned, the return statement sends the calculated average back to where the function was called. Now, whenever we call calculate_average with some numbers, it will give us the average of those numbers. Now it's time to test. So let's test our function with some examples to make sure it works. So I will call calculate_average with a few sets of numbers and print the results. So the first test calls calculate_average 10, 20, and 30. The average of 10, 20, and 30 should be 20. The next test calculate_average for 5 and 15. And the last test calculates the average with no passed arguments. So we expect in this test the output will be none. Now let's execute our code using Python 3 from terminal. Then the name of the file lab_2.python. Now press enter, and as you see from the output, we have the average for 10, 20, and 30, which is 20. We have the average of 5 and 15, which is 10, and without any passed arguments, it printed none as expected. So that's it. We have created a function that can handle any number of arguments and calculate their average. This exercise showed us how asterisk args can make functions more flexible by allowing them to work with varying numbers of inputs. Thank you. Keep practicing to get comfortable with these concepts, and see you in the next lesson. Hello and welcome to a new lesson on Lambda functions. In this lesson, we will explore what Lambda functions are, why they are incredibly useful, and how to apply them in real-world scenarios. By the end of this lesson, you will know how to use Lambda functions for tasks like sorting, mapping, and filtering. So, let's dive in. Alright, let's start with the basics. So, what exactly is a Lambda function? Think of it as a small anonymous function, one that doesn't have a name. It's perfect for quick tasks where defining a full function might feel like overkill. The syntax is super simple. Lambda followed by the arguments, a colon, and then the expression. The result of that expression is automatically returned. This makes Lambda functions compact and efficient. Here is a quick example to see Lambda functions in action. We are defining a Lambda called add, which takes two arguments, x and y, and returns their sum. When we call it with the numbers 3 and 5, we get 8. Simple, right? It is just like a regular function, but without the overhead of naming it or defining it separately. Now let's look at how Lambda functions can make sorting easier. Imagine you have a list of tuples where each tuple contains a server name and a number. We want to sort this list by the number using the sortD function with a Lambda. We can specify the sorting key, in this case, the second element of each tuple. And just like that, we have our list sorted. No need for complex logic or additional functions. Moving on to map. This function is great for applying a transformation to every element in a list. Here we have a list of CPU core counts, and we want to double each value. The Lambda function multiplies each number by 2, and map handles the rest. The result, a new list with all the values doubled. Easy and efficient. Next up, filter. This is perfect for extracting specific elements from a list based on a condition. For instance, let's say we have a list of server loads and we want to find the high load servers, those with a load greater than 0.7. The Lambda function checks this condition and filter gives us the filtered list. It's as straightforward as that. To wrap things up, why use Lambda functions? They are concise, making them perfect for quick tasks. They are powerful when combined with tools like map, filter, and sorted. And they simplify your code, making it more readable. Lambda functions are a handy addition to your Python toolkit, especially for tasks in DevOps and automation. Before we go, here is what's next. Try exploring more use cases for Lambda functions. Play around with combining them with advanced Python features, and most importantly, keep practicing. The more you use Lambda functions, the more natural they will feel. Thanks for joining me in this lesson, and I will see you in the next one. Hello and welcome to our practical lesson on Lambda functions. In this lesson, we will filter out odd numbers from a list of integers using a Lambda function. Let's start by defining a list of integers. So, in this line, I have created a variable called numbers and assigns it a list of integers from 1 to 10. This list will serve as our input data. Then we will apply a filter to remove odd numbers. Next, we will use the filter function along with a Lambda function to filter out the odd numbers. So, here is our line of code that will do that. So first, we are defining a variable called even_numbers. This will store the filtered list of even numbers. The filter function is used to filter the elements in the numbers list. It takes two arguments. The lambda function, which I wrote as lambda x2.x modulus 2 equal 0. This checks if each number x in the list is divisible by 2. If true, the number is kept, otherwise it's filtered out. Then we have the numbers list, which is the data we are filtering. Since filter function returns a filter object, we use list function to convert it into a regular Python list so we can work with the result more easily. Finally, let's print the list of even numbers, so we will use the print function to print the list of even numbers. Now let me save the file. And now from the terminal, let's use Python 3 to execute this code, which we wrote inside lab3.py. And as you see, here is the even numbers 2, 4, 6, 8, and 10. And by that, we get to the end of our lesson. Thank you for watching and see you in the next one. Hello and welcome to a new lesson on modules and packages. In this lesson, we will explore what modules and packages are, why they are incredibly useful, and how to import and use Python's built-in modules. We will also dive into practical examples using the OS and sys modules. So let's get started. First, let's define what modules and packages are. A module is just a file that contains Python code, things like functions, classes, or variables that you can use or reuse in your program. A package is a collection of related modules organized into directories, which makes it easier to manage and use them together. So, why use modules and packages? They save you time by letting you reuse code that's already been written, and they give you access to powerful built-in functionality without having to reinvent the wheel. Plus, they help you keep your code organized and manageable. Now let's talk about importing modules. The syntax is simple. You use the import keyword followed by the module name. For example, to import the OS module, you just write import OS. When you import a module, Python loads its functionality into your program. You can then access the functions, classes, and variables from that module using dot notation. Let's see some examples in action. Our first example uses the OS module. The OS module is great for interacting with the operating system. Here is the code. Import OS, then print function os.listDir, then dot. This code imports the OS module and then calls the os.listDir function. The dot tells it to list the content of the current directory. When you run this, it will display all the files and folders in your current working directory. It's a simple and handy way to explore your file system programmatically. Next, let's look at the sys module. The sys module allows you to interact with system-specific parameters and functions. Here is an example. Import sys, print sys.argv. This code imports the sys module and then prints the sys.argv list. Now let's summarize what we have learned. Modules and packages are great tools for writing cleaner and more efficient code. Python's built-in modules like OS and sys offer powerful functionality that saves you time and effort. Using these modules avoids the need to reinvent the wheel and helps you get more done with less code. Finally, what's next? Try exploring more built-in modules like math for mathematical operations, datetime for working with dates and times, and random for generating random values. You can even experiment with combining multiple modules in one program to see how they work together. The more you practice, the more confident you will become in using Python's modules and packages. Thank you for following along, and I will see you in the next lesson. Hello and welcome to our practical lesson on importing built-in modules in Python. Let's start by importing the time module. So I will type here import then time. So this line imports the built-in time module, which provides various time-related functions. We will use this module to measure the execution time of a function. Next, let's define a simple function. So I will create a function called my underscore function. This function will just pause for a couple of seconds using the time.sleep function, and I will put here to pause for 2 seconds. So here I have defined a function named my underscore function. Inside this function I have used timesleep2 to make the program pause for 2 seconds. This simulates a task that takes some time to execute. Now let's measure how long it takes for this function to run. So let's type here start time equal to time.time. And here I will call my function. Then finally, let's define a variable end underscore time equal time.time. So what is happening here? So first I defined a variable start underscore time equal time.time, which record the current time in seconds. Then we call my function. This is the function whose execution time we want to measure. Finally, in time equal time.time records the time again after the function has finished executing. So this is our ending point. Lastly, let's calculate the total execution time and print it. So let me type here execution underscore time equal end underscore time subtract start underscore time. Let's also use the print function to print execution time, then the value of execution underscore time in seconds. So here I calculate the total execution time by subtracting start underscore time from end underscore time. The result is the number of seconds the function took to execute. Then I use a formatted string to print the result as execution time. Then it will provide the time in seconds. Now let's run this code and see the output. So from the terminal I will use Python 3, then our file name, which is lab_4.py. And as you can see from the output, it took 2 seconds. To recap, we first imported the time module, then we defined a function that simulated a task by sleeping for 2 seconds, then measured the time before and after calling the function using time.time. Finally, we calculated the difference to get the execution time and printed the result. And that's it for this lesson. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson on creating custom modules and packages. In this lesson, we will explore how to define your own modules and packages and why they are so useful. We will also look at practical examples of creating and using them. So let's dive in. Let's start with some definitions. A custom module is simply a Python file that contains reusable functions, classes, or variables. You can write your own module to organize code and use it in multiple projects. A custom package, on the other hand, is a collection of related modules organized into a directory. It helps you manage and group multiple modules together in a structured way. Why bother creating these? Well, it improves code reuse. You don't need to rewrite the same functions over and over, and it makes your code more organized and easier to maintain, perfect for both small and large projects. Now let's talk about how to create your own custom module. Step 1. Create a new file named math_utils.py. In this file, you can define functions or other usable code. Let's look at an example. Here we have defined two simple functions, add and subtract. These can be used for basic arithmetic operations. Step 2. To use this module, simply import it into another script like this. By using import math_utils, you load the module and can access its functions using dot notation. It is very simple. Now let's take it a step further and create a custom package. Step 1. Start by creating a folder named file_utils. Inside this folder, add a file called __init__.py. This file can be empty, but it tells Python that this folder should be treated as a package. Add another file named file_operations.py. In this file, we will write a function to list files in a directory. Step 2. To use this package, import the file_operations module like this. From file utils, import file operations. This will list all the files in the current directory, so using packages lets you group related modules together and makes your code easier to manage. Let's review the key points. Custom modules. These are individual .py files containing reusable code. You can import them using the import statement. Custom packages. These are directories containing multiple modules organized to work together. They include an __init__.py file to tell Python that the directory is a package. Both modules and packages help you write cleaner, more maintainable code. Finally, here is what you can do next. Try creating your own custom modules for common tasks like string utilities or math operations. Then take it further by building a package with multiple modules for a large project. You can even explore sub-packages for more complex organization. With practice, you will find that creating and using your own modules and packages can save you a lot of time and effort. Thanks for joining this lesson, and I will see you in the next one. Hello and welcome to our new exercise on creating a custom module for file operations. Let's start by creating a new Python file for our custom module. I will name the file file_utils.py. So from the terminal, I will create the file. Now let's define a function for writing to a file. In this function, called write_to_file, we take two arguments. File name, which is the name of the file we want to write to, and content, which is the text we want to write. We use the open function with wmod, which stands for write mode. The with statement ensures the file is properly closed after writing. Finally, the write function method adds the content to the file. Next, let's add a function for reading the content of a file. This function called read underscore from underscore file. It takes a single argument, file name, which is the name of the file to read. Again, we use the open function, but this time with the R mode, which stands for read mode. The read function method retrieves the file's entire content and returns it. The with statement ensures the file is properly closed after reading. Now that we have defined our functions, let's test the module by importing in another script. So I will go to lab_5.py, then I will write here import file underscore utils to import the file utils module. Now let's write inside this file. So I will write file underscore utils module, then dot, then I will call the write to file function from inside the file utils module. And as we remember, this function takes two arguments. The first one is the file name, which will be example.txt, and the second argument, the content we will write inside the file, which is hello, Python. And after that, let's read from the file. So I will define a variable here, content, which will equal to, then it will equal to file utils dot the read from file function, which inside the file utils module. And this function take only the file name, which is example.txt. Finally, I will print the content, and let's explain again this code. So first, we import the file underscore utils module so we can use the functions we just created. Then we call the write to file function to create a file named example.txt and write the text hello Python into it. Next, we call the read underscore from underscore file function to read the content of the example.txt file. Finally, we print the content to verify that it worked correctly. To validate our work, I will execute Python 3, then lab_5.py. Now press enter, and as you can see, the output is exactly as we expected, hello Python. So to summarize, we created a custom module named file utils, and we defined two functions: write to file for writing content to a file, read from a file to reading content from a file. Then we tested the module by importing it and verifying the functionality. This exercise demonstrates how you can encapsulate reusable file operations in a custom module. Thank you for watching, and see you in next lesson. Hello and welcome to a new lesson on understanding scope and namespaces in Python. In this lesson, we will explore how Python determines where variables are accessible, the difference between local and global scopes, and how nested functions use non-local variables. By the end, you will have a clear understanding of how scope and namespaces work in Python. First, let's define what we mean by scope and namespaces. Scope refers to the region of a program where a variable is accessible. Python has three main types of scope: local scope, which is variables declared inside a function; global scope, variables declared outside all functions; and non-local scope, variables in an enclosing function accessed within a nested function. Namespace, on the other hand, is like a dictionary that maps variable names to their objects. Python has different types of namespaces: local namespace, variables inside a function or block; global namespace, which is variables at the module level; and built-in namespace, variables, and functions provided by Python's standard library. Understanding these concepts helps you write cleaner, more efficient code while avoiding unintended overrides. Let's look at an example to understand the difference between local and global scope. At the top, we define a global variable x with a value of 5. Inside the change_value function, we use the global x keyword. This tells Python that we are referring to the global x, not creating a new local variable. When we assign x equal 10, it updates the global variable x to 10. Finally, the print x statement displays the updated value of x, which is now 10. This demonstrates how you can use the global keyword to modify global variables inside a function. Now, let's move on to nonlocal scope, which is used in nested functions. We start with a function called outer_function, which defines a variable x with the value outer. Inside outer_function, there is another function called inner_function. This is a nested function. In inner function, we use the nonlocal x keyword. This tells Python that we are referring to the x variable from the enclosing outer_function, not creating a new local variable. When we assign x equal to inner, it updates the value of x in outer_function. The print statement inside inner_function and outer_function show how the value of x changes from outer to inner. This demonstrates how nested functions can access and modify variables in their enclosing function using the nonlocal keyword. Now let's summarize what we have learned. We learned local scope, which is variables declared inside a function are only accessible within that function. We learned global scope. Variables declared outside all functions are accessible throughout the module unless shadowed by local variables. Non-local scope. Variables in the enclosing function of a nested function can be accessed and modified using the non-local keyword. Understanding scope is essential for avoiding unintended overrides, especially in larger programs. It also helps you write better, organized, and more readable code. Finally, here are some ideas to practice what you have learned. Experiment with the global and non-local keywords in different contexts. Try creating nested functions with multiple levels of scope. Explore potential namespace conflicts, like when local and global variable or variables have the same name, and learn how to resolve them. By practicing these concepts, you will become more confident in working with the scope and namespaces in Python. Thanks for joining this lesson, and I will see you in the next one. Hello and welcome to a new lab on experimenting with global and non-local in nested functions. Let's start by creating a simple nested function structure. So I will copy and paste the code for the outer and inner function first. So first we defined an outer function that contains a variable x initialized with the value outer. Inside outer_function, we have defined a nested function called inner_function. Inner_function simply prints the value of x before making any changes. Finally, we call inner_function from within outer_function and print x again. This is the baseline setup to observe how variables behave in different scopes. So let's execute our code using Python 3, then the name of the file lab_6.py. And of course, we didn't get any output because we didn't call our function. So here, let's call the outer function. And now let's execute our code again. And as you see, it printed out before modification in inner function outer, and after calling inner function in outer function outer. Next, let's use the nonlocal keyword inside the inner function to modify x. So in the inner function, I will add here nonlocal x, then x equal inner, and I will change the print message to be after modification in inner function. So what I did here, inside the inner underscore function, I have added the nonlocal x statement. This tells Python to use the x variable from the enclosing outer underscore function scope instead of creating a new local variable. When we assign x equal inner, it modifies the value of x in outer function. The first print inside inner underscore function shows the updated value of x. The second print inside outer underscore function confirms that x has been modified in the outer scope. So this demonstrates how nonlocal allows us to modify variables in an enclosing scope. So now let's execute our code. And as you see, now the x has been modified to be inner. Now let's add a global variable and experiment with the global keyword to see how it works. So here, before the outer function, I will define a variable x equal to global. Then I will remove this line from the outer function, and inside the inner function, let's type global x. And we will change the x here to be modified global. I will also change the print statement here to be inside inner underscore function with global. And I will also change the second print statement here to be after calling inner function in outer function. Then we will call our outer function, and I will print outside all functions to print the x value. So what I did here, at the top, I have added a global variable x with value global. Inside inner underscore function, we use the global x statement. This tells Python to refer to the global x instead of creating a new local variable. When I assigned x equal to a modified global, it updates the global variable. The first print inside inner underscore function shows the updated value of the global x. The second print inside outer underscore function doesn't access x because there is no x in its local scope. Finally, the last print outside all functions confirms that the global variable has been modified. This demonstrates how the global keyword allows you to modify global variables from within a function. To test our work, I will execute our Python code. And as you see, the inside inner underscore function with global, the x is modified global. After calling inner underscore function in outer underscore function, x is modified global. Outside all functions, modified global. So to recap, we have created a nested function and observed how variables behave in local and outer scopes. Used the nonlocal keyword to modify variables in an enclosing scope, and we used the global keyword to modify variables at the global level. Experimenting with these concepts help you understand how Python manages a variable scope, which is essential for writing clean and predictable code. Thank you for watching, and see you in the next lesson. Hello and welcome to a new lesson on file operations in Python. In this lesson, we will learn how to work with files, including reading, writing, and appending data. File operations are a crucial skill for any Python developer, especially when working with DevOps and Linux environments. To start, let's see how to read file using Python. Here is an example. We open a file called example.txt in read mode using the open function. The R mode is specifically used for reading. Next, we use the read method to load the entire file content into a variable. Finally, we print the content and close the file using the close method. It's important to always close the file after you are done to free up system resources. While the open function works, there is a better way to manage files in Python using the with open statement. This method ensures that the file is automatically closed after the operation, even if an error occurs. In this example, we open the same file, but instead of reading the entire content at once, we read it line by line using a loop. Each line is stripped of unnecessary white space before it is printed. This is cleaner, safer, and more Pythonic way to handle files. Sometimes files can be very large, and reading the entire file into memory isn't practical. In such cases, we can read the file in smaller chunks. Here is an example where we use a while loop to read 1024 bytes at a time until the end of the file is reached. This approach is efficient for handling large files in a controlled manner. Now let's look at how to write to files. In this example, we open a file called output.txt in write mode using the W flag. The write method allows us to add text to the file. Keep in mind that write mode overwrites the file if it already exists. If the file doesn't exist, Python will create it for you. What if we want to add more content to an existing file without overwriting it? That's where append mode or A comes in. In this example, we open output.txt in append mode and add a new line at the end of the file. This mode is perfect when you want to preserve the existing content while adding new data. Before we wrap up, here are some best practices for file operations. Always use with open to handle files whenever possible. If you use the open function directly, remember to close the file manually. Choose the correct mode R, W, or A based on what you need to do. For large files, read in chunks to avoid memory issues. By following these steps, you can handle file operations in Python effectively and efficiently. This concludes our lesson on file operations. Practice these examples to build confidence and remember to implement these best practices in your project. Thank you for watching and see you in next lesson. Hello and welcome to the lab on file operations. In this lesson, we will write Python code together to demonstrate how to read from, write to, and append to files. So let's get started. Let's begin with reading data from a file. First, I will create a text file named example.txt and add some sample content to it. So from the terminal, I will execute touch example.txt to create the example.txt file. Then I will open the file and I will add hello Python, welcome to file operations. Let me save the file and let's go back to our code. So let's define a variable here, file equal, then open function, then the file name, which is example.txt, and R for read mode. So here we use the open function with the R mode to open the file for reading. Now let's define the content variable equal to file.read method. The read method loads the file's entire content into a variable. Now let's print the content using the print function. And finally, don't forget to close the file with close function. So let's type here file.close. And now we are done with our code. Let's test our code from the terminal using Python 3. Then the name of our file for this lab_1.py. Now press enter. And as you see, the output is the content of the example.txt file. Hello Python, welcome to file operations. Now let me comment this code. So now let's make the code more efficient using with open. This ensures the file is automatically closed after use, even if an error occurs. So I will type here with open, then the file name, example.txt, then read mode, then as file, and here we open the file using with open. Now let's type for line in file. So now we are looping through each line. Then using the print function, I will add here line.strip. And the strip method removes any extra white space or new line characters. Now let me save this file and let's execute our code. And as you see, the output is as we expected. Hello Python, welcome to file operations. Okay, now let me comment this code for with open. Sometimes files are too large to read all at once. Let's read the file in chunks of 1024 bytes. So I will use also with open example.txt with the R mode as file. And here I will type while chunk equal to file.read, then 1024 bytes, then print chunk. So in this example, we use a while loop to read the file in chunks of 1024 bytes at a time. The two dots equal operator, also known as the walrus operator, assigns and evaluates the chunk in one step. Now after saving the file, I will execute our Python code, and as expected, the output is hello Python, welcome to file operations. Let me comment this. And next, let's write some data to a new file. We will create a file called output.txt and add some text to it. So this time I will type with open, then the name of our file we want to create, which is output.txt. And since I am writing to a file, I will use the W mode, then as file. Now I will use the write method. So I will type here file.write, then our strings that will be written to the file. So we will write, this is an example of writing to a file. I will write another line using the write method. And this time I will write another line of text. So here we use the W mode to open the file in write mode. If the file doesn't exist, it will be created. The write method adds text to the file. Let's run this and check the content of output.txt. So first I will do ls here, and as you can see, the output.txt file is not exist yet, or doesn't exist yet. Now I will execute the code using Python 3, then the name of the file. Now let's execute ls and enter. And as you see now, we have output.txt. To validate our work, I will display the content of output.txt using the cat command. And as you see, the file has the content we wrote inside the output.txt. This is an example of writing a file and another line of text. Finally, let's append some additional text to output.txt. This is useful for preserving existing content while adding new information. So using the same code with open output.txt, but this time I will add here a mode for appending. And I will only append a new file using the write method. And let's add append line. So in this example, we use the a mode to open the file in append mode. This ensures that the new line is added to the end without overwriting the existing content. Let's run this and check the updated output.txt. So I executed the lab_1.py. Now let's print the content of output.txt. And as you see, the new line appended successfully. That's it for this lab. We have covered reading files entirely, line by line and in chunks, writing to files, appending to files. These are essential skills for any Python developer, especially in DevOps or Linux-based roles. Remember to practice these examples and explore additional options like handling exceptions for missing files. And by that, we get to the end of our lesson. Thank you for watching and see you in the next lesson. Welcome to this lesson on working with directories in Python. In this lesson, we will explore how to manipulate directories and files programmatically using two powerful modules, OS and shutil. By the end of this lesson, you will be able to create, list, copy, move, and delete directories and files with ease. Let's start with creating a new directory using the OS module. Here is how it works. We import the OS module and call the mkdir function to create a directory named logs. This is a straightforward, but make sure the directory doesn't already exist. If it does, you will get an error. To avoid errors, it's a good idea to check if the directory already exists before creating it. In this example, we use os.path.exists to check if directory logs exists. If it doesn't, we create it using mkdir. This is a simple way to ensure your script doesn't fail unexpectedly. Now let's list all the files and directories in the current working directory. Using os list_dir dot, we get a list of everything in the current path. The dot represents the current directory. When we print the list, we can see all files and folders. This is especially useful for understanding the directory structure or debugging. Next, let's look at the shutil module, starting with copying files. In this example, we use shutil copy to copy a file named example.txt to a new file called backup.txt. The first parameter is the source file and the second is the destination. This is great for creating backups of important files. Now let's move a file using shutil.move. Here, we move example.txt to a folder named archive. If the folder doesn't exist, you will need to create it first. Moving a file can also rename it if the destination has a different file name. Finally, let's delete a directory and all its contents. We use shutil.rm3 for this. In this example, we delete the directory named archive, including all files and subdirectories inside it. Be cautious when using this function as it is irreversible and removes everything in the specified directory. To wrap up, we have seen how to use the OS module for basic file and directory management, such as creating and listing directories. We have also explored the shutil module for higher level operations, including copying, moving, and deleting. These tools are invaluable for automating directory management tasks in Python. Practice these examples and you will be well equipped for managing files and directories programmatically. Thank you for watching and see you in the next lesson. Hello and welcome to this hands-on lab on working with directories in Python. In this lesson, we will write code together to explore the OS and shutil modules. These modules allow us to manage directories and files programmatically. Let's dive into the first task. First, let's create a directory. Imagine we need a folder named logs to store log files. We will use the OS module for this. Let's start by importing the OS module and calling the mkdir function. So let's write together import OS, then os.mkdir method, then the name of the folder or directory we want to create, which is logs. So this code creates a new folder named logs. If the directory already exists, Python will throw an error. Let's run this code, but first let's check if there is any logs directory here. So no logs directory. Now let's execute our code using Python 3 and our file name, which is lab2.py. So now we have the logs directory created. Let's try to execute the code again one more time. And as you see, we got an error, file exists. To avoid errors when creating directories, we should first check if the folder exists. So let's add a check using os.path.exists. So here I will use the if condition, then not os.path.exists, then the name of the directory we want to create. Then under the if condition, we will make the directory using os.makedir. So here we use the os.path.exists to check if the directory logs exists. If it doesn't, the script creates it. Let's run this code and verify that it works correctly. But first, I will remove the logs directory using the rm command. And let's execute ls and enter. And here we don't have logs directory. Now let's execute our code and ls. And here we have the logs directory. Let's try to re-execute the code again. And this time we didn't get any error because we added the check first to check if the logs directory exists. If it exists, then the code will not do anything. If it doesn't exist, then the code will execute os.makedir logs and create the logs directory. Next, let's list all the files and directories in the current working directory. This is useful to see what's inside a folder. So let me first comment this part of code. And now let's define a variable with the name files, and this variable equal to os.listdir. Then I want to list all files and directories inside the current directory, so I will add dot here. And using the print function, let's print the file's value. So here we use the os.listdir dot to list the contents of the current directory. The dot, as I mentioned, refers to the current path. Running this will display all files and folders, including the logs directory we created earlier. To validate our work, let's execute our code. And as you see, we have all files and directories in a Python list. And here we have the example.txt and the output.txt from our previous lessons, and we have the logs directory that we just created. Okay, now let me comment all the code here to move to the second topic of this lesson. So I will comment this part. And now let's use the shutil module to copy files. For this example, we will copy a file named example.txt to a new file called backup.txt. So first, let's import our module, which is shutil. And let's type shutil, and we will use the copy method. And first, our source, the file we want to copy, example.txt, then the destination, which is backup.txt. So here the shutil.copy function takes two arguments, the source file and the destination. This is great for creating backups or duplicating files. Let's run the code and check if backup.txt has been created. So let's execute our code. Let's type ls and enter. And as you see, right now we have a copy from the example.txt file with the name backup.txt. Okay, now I will just comment this shutil copy. Now let's move a file to another directory. Suppose we have a folder named archive where we want to store old files. We will move example.txt into that folder. So let's type shutil, then I will use the move method, then our source file example.txt and our destination, which is archive, then example.txt. So the shutil.move function moves a file to a new location. If the destination directory doesn't exist, you will need to create it first. So we didn't create the archive directory yet. So let's create it using the mkdir command. And of course, you can create it with the OS mkdir. But for now, I will just use the mkdir archive. Now we have the archive directory, and if we execute it ls on the archive directory, as you see, there is no output, which means that archive is empty directory. Now let's execute our Python code, and let's validate our work by executing ls archive. And as you see, under ls archive, there is example.txt. If we execute it ls on the current directory, as you see, there is no example.txt file here. That's because we moved the example.txt file from the current working directory to the archive directory. Okay, now let's comment this line. And finally, let's delete a directory and all its contents. So we will remove the archive folder. So using shutil.rm3 method, then the directory we want to remove, which is archive directory. So the shutil.rm3 function removes the specified directory along with everything inside it. Be very careful with this function as it is irreversible. Now let's run our code to verify that the archive folder will be deleted. Now let's execute ls, and as you can see, the archive folder has been deleted. Now I can say congratulations, you have completed the lab on working with directories using the OS and shutil modules. In this lesson, we created directories and checked their existence using the OS module. listed files and directories in the current path. Use the shutil module to copy, move, and delete files and directories. These skills are essential for automating file and directory management tasks in Python. Keep practicing and see you in the next lesson. Hello and welcome to a new lesson on parsing configuration files. Configuration files are widely used to store application settings and preferences in a structured way. The most common formats we will cover in this lesson are INI, JSON, and YAML. In this lesson, we will learn how to read and write these formats using Python. Let's begin with INI files, which organize settings into sections and key value pairs. Here is how you can read an INI file using the config parser module. First, we create a config parser object and use the read method to load the file. Then we access the values like a dictionary, specifying the section and key. In this example, we are reading the value of log_level from the default section of the file. This is a simple way to manage configuration settings. Next, let's write to an INI file. We add a new section called new_section and provide a key value pair. Then we open the file in write mode and use the write method to save the changes. This approach allows us to update or expand configurations programmatically. Now let's move on to JSON files, which are structured as key value pairs and are commonly used for APIs and configurations. Using the JSON module, we can read a JSON file by opening it in read mode and calling json.load. This converts the JSON data into a Python dictionary, making it easy to access the values. In this example, we print the value associated with the key. JSON is great for structured, machine-readable data. To write data back to a JSON file, we use the json.dump method. After opening the file in write mode, JSON_dump takes the dictionary and saves it to the file. Adding an indent parameter ensures the output is formatted for readability. This is common practice when saving configuration updates or structured data. Finally, let's look at YAML, which is designed to be human-readable and supports complex structures. Using the YAML module, we open the YAML file in read mode and call save_load to parse its content into a Python dictionary. In this example, we print the value of the key. YAML is especially popular in DevOps for tools like Ansible and Kubernetes. To write data back to a YAML file, we use save_dump from the YAML module. After opening the file in write mode, we call save_dump to save the dictionary to the file. This ensures the YAML format remains valid and compatible. YAML's simplicity and flexibility make it ideal for configuration files. Now let's summarize what we have learned in this lesson. For INI files, we use the config parser module to manage sections and key value pairs. For JSON files, the JSON module allows us to work with structured data. For YAML files, the YAML module makes it easy to handle human-readable configurations. By understanding these formats and how to parse them, you can efficiently manage configuration files for any Python project. Thank you for watching, and I will see you in the next lesson. Hello and welcome to this hands-on lab on parsing configuration files in Python. In this lab, we will write code together to read and write configuration files in three popular formats: INI, JSON, and YAML. By the end of this lesson, you will have a practical understanding of how to handle these file types for real-world projects. So let's get started. Let's begin by working with an ini file. Imagine you have a configuration file named config.ini that contains application settings. First, let's create this file and add some content to it. So in the terminal, I will create the file using the touch command, then the file name config.ini. Now let's edit the file and let's add a default section to it and log level equal info. Now let's write a Python script to read log_level value. Let's import the config parser module and let's define a variable config equal to config parser dot config parser method. Then config dot read, then our file, the ini file, which is config.ini. Finally, we will print the section and the log level. So print config, then we want the default section, and from the default section we want to get the value of log level. So what we did here, first we imported the config parser module. We loaded the config.ini file using the read method and accessed the log_level value from the default section. Let's run this script and verify our output. So from the terminal using Python 3, then our file for this lab 3.py. Now let's execute it, and as you see, the output is the log level from the config.ini, which is info. Next, let's add a new section to the ini file and write it back to the config.ini file. We will programmatically add a section named new_section with a key value pair. So let's see how we can do that. So to add a new section, I will type here config, then the new section we want to add, which is new_section, equal to then the key and the value we want to add as dictionary. So here we will type the key and its value. Then we will open our config.ini file. So let's type with open, then the name of our config file, which is config.ini, and we want it in a write mode, so I will add w here, then as config file. Now let's use the write method, so I will type here config.write, then we will write that to the config file. So in this code, we added a new section to the config object and use the write method to save the changes to config.ini. Let's execute this script here using the Python lab_3.py file. So the output, of course, is info here because we have a print message for info, but to validate that we have added a new section with the key and value inside config.ini, let's open the file, and as you see here, we have the new section with the key and value. Now let's switch to JSON. JSON files are structured as key value pairs, commonly used in APIs and modern applications. First, let's create a JSON file named config.json and add some content to it. To do so, I will execute touch, then config.json. Now let's open config.json and let's add this simple JSON format with key and its value. Now let's go to lab 3 and let me comment the config parser section here for INI file. And for JSON, let's write a code to read the value associated with the key. So first, let's import the JSON module so that we can deal with JSON format and JSON files, of course. To open the JSON file, I will type with open, then the JSON file name, which is config.json, and I will open the file in read mode. So I will add R here, and of course I will open this config.json file as file. Now let's define a variable data equal JSON.load to load our file. Finally, I will use the print function to get the value of the key. So it will be data, then key. So here we use the JSON module to load the JSON file into a Python dictionary. The JSON.load function converts the JSON data into a format we can easily manipulate. Let's run this code and see the output. So from the terminal, I will execute python3 lab_3.py. And as you can see, the output as expected is value. Next, let's update the JSON data and write it back to the file. We will add a new key value pair and format the output for readability. So I will add a new key with the name new key. To do so, I will type data, then the new key we want to add, which is new key, and that will be equal to a new value. Now we want to open config.json in write mode. So let's type with open, or simply let me copy this here. And let's change this to be write mode. To write inside JSON, we will use the dump method. So let's type json.dump, and we want to dump the data, and we will pass the file and indent equal 4. So in this code, we modify the data dictionary and use json.dump to save it back to the file. The indent equal 4 parameter ensures the file is formatted for easier reading. Let's execute this code. And as you can see, we have the value from the first print statement here. Let's go to the config.json, and as you see, a new key added with the value new value. Finally, let's work with YAML. YAML is often used in DevOps tools like Kubernetes and Ansible due to its simplicity. First, let's create a YAML file named config.yaml. So I will execute touch config.yaml. Let's edit the config.yaml file and let's add this content here, key and value. Let's comment this code in our lab file. Now to work with YAML, we need to import YAML module. I want to open the config.yaml file in read mode, so I will type with open, then the name of the config.yaml file, then read mode. After that, I will define a variable data, then I will load this file to it using YAML.save_load, then file. Finally, I want to get the value of the key from this YAML file, so I will use print function, then data and the key to get the key value. Let's execute this code, and as you see, the output is value, which is exactly the value of the key here inside the config.yaml file. So in this code, we use the YAML module and call save_load to parse the file into a Python dictionary. This makes it easy to access the values. Lastly, let's update the YAML data and write it back to the file. We will add a new key value pair and save the file. So type data, then the new key we want to add that will equal to the new value we want to add. Now I want to open the config.yaml file in write mode, so we will type with open, then the file name and W, then it will be opened as a file. Then let's type yaml.save dump, then the data we want to add and the file. So in this code, we modify the data dictionary and use save dump to save it back to the YAML file. Let's run this script, then check config YAML to see the updated content. So I executed the script. Let's go to the config.yaml file, and as you see, the new key has been added with its value, new value. Now we have successfully completed the lab on parsing configuration files. Here is what we covered in this lab: reading and writing INI files using config parser, handling JSON files using the JSON module, and working with YAML files using the YAML module. These are essential skills for managing application settings and preferences. Thank you for watching, and see you in next lesson. Welcome to this lesson on exception handling in Python. Exceptions are errors that occur during the execution of a program. Instead of letting these errors crash your program, Python provides a mechanism to handle them gracefully. In this lesson, we will cover how to use try, except, else, and finally blocks, how to raise exception, how to create custom exception classes. Let's begin with basic exception handling using try, except, else, and finally blocks. Here is an example where we attempt to divide 10 by 0, which raises a 0 division error. The try block contains the code that may raise an exception. If an exception occurs, it's caught and handled in the except block. The else block is optional and runs only if no exceptions occur. Finally, the finally block runs regardless of whether an exception occurs. Now let's learn how to raise exceptions explicitly. Here is an example function validate_age, which checks if the input age is valid. If the age is less than 0, the function raises a value error with a custom error message. By using the raise statement, we can ensure the program stops and alerts us to invalid inputs. Sometimes we need to raise a new exception while preserving the context of an original error. Here is an example where we first raise a value error. Then inside the except block, we raise a runtime error and chain it to the original error using raise from. This technique is helpful for debugging as it maintains a trace of the original error. Next, let's talk about creating custom exception classes. We define a class called custom error, which inherits from Python's built-in exception class. Inside the class, we define an __init___ method to initialize the exception with a message. Custom exceptions are useful for handling application-specific errors. In this example, we raise a custom error with a specific error message. Inside the except block, we catch the exception and print its message. Custom exceptions allow you to handle errors in a way that's tailored to your application's needs. To summarize, we have covered the essentials of exception handling in Python: the try, except, else, and finally blocks for managing exceptions. the raise statement for triggering exceptions, and raise from for chaining errors. Creating custom exception classes to handle specialized error scenarios. Exception handling is a critical skill for writing robust and error-tolerant Python programs. Practice these techniques to improve your error handling abilities. Thank you for watching and see you in the next. Welcome to this hands-on lab on exception handling in Python. In this lesson, we will write code together to practice handling errors gracefully using try, except, else, and finally blocks. We will also raise exceptions and create custom exception classes for specific scenarios. Let's begin by handling a basic exception. Imagine we have a piece of code that attempts to divide a number by 0. This will raise a zero division error. Our goal is to handle this error and ensure the program doesn't crash. So let's see the zero division error together. So here I will define a variable result, and this result will equal 10 divided by 0. Now let's print the result and let's execute the code using Python 3 and our file lab4.py. As you see here, there is an error, zero division error divided by 0. Now let's see how we can handle this error and ensure the program doesn't crash. So let me delete this code here and let's type try. Then we will define the result equal to 10 divided by 0. Then accept. And we want to handle the zero division error. So I will type zero division error as E. Then print error, comma, E. After that, we will do else statement and we will print no error occurred. Finally, let's add the finally block and we will print this will run regardless of errors. So here is what's happening. The try block contains the risky operation. The accept block catches the zero division error and prints an error message. The else block runs if no exceptions occur, but it will be skipped in this case. The finally block always executes, ensuring cleanup tasks can run regardless of errors. Now let's execute this code and observe how each block behaves. So I will execute Python 3, then lab_4. And as you can see, because we have the zero division error, we now can see the first print statement, which is error, then division by 0. And also the final block has been executed and we have this will run regardless of errors. Okay, now let's comment this block of code. And let's move to our next topic. Now let's learn how to raise exceptions intentionally. Imagine you are building a function to validate a user's age. If the input age is negative, it doesn't make sense. So we will raise value error with a custom error message. Let's write our function together. So I will write a function. Our function name will be validate_age, and it takes one parameter here, which is age. Then we will do an if statement to check if age less than 0. If the age is less than 0, then we will raise a value error and we will print age cannot be negative. Then we will print the valid age and the age. Now let's call this function with a negative value -5. So in this code, we use the raise statement to trigger a value error if the age is less than 0. If the age is valid, it prints a confirmation message. Let's run this code. So I will type here Python 3, then lab_4.py. And as you can see here, we raised the value error, age cannot be negative. Okay, now let's try with a valid age, 20 for example. Let's execute the code again. And as you can see, it printed the valid age, 20. Now let's comment this code. Sometimes you might need to raise a new exception while preserving the context of an original error. Let's practice chaining exceptions using raise from. We will simulate an initial error, catch it, and then raise a new error, link it to the original one. So let's add a try block here, and we will raise a value error, original error. Then our accept block, and accept value error as E. Then we will raise a runtime error, new error from E. In this example, we first raise a value error. In the accept block, we catch the error and then raise a runtime error, linking it to the original error using raise from. This technique is useful for debugging complex issues. Let's run this code and see the chain of errors in the output. So let's run the code. And as you see, the value error, the original error, and here's the runtime error with the new error. Now let me comment this code here. Now let's create a custom exception class. Imagine you are writing an application where certain errors need to be handled in a unique way. A custom exception allows you to define a specific error type with its own attributes. So let's define a class called custom error. Under this class, I will define the init function. So it will be like this: def __init _self, message, then self dot message equal message. So this code defines a custom exception class by inheriting from Python's built-in exception class. It includes an __init__ method to initialize the error with a specific message. Now let's see how to use this custom exception. Let's raise and handle our custom exception. We will trigger a custom error with a custom message and catch it in a try except block. So let's add our try block here, then our except block. And in this code, we raise a custom error with a specific message. The accept block catches the error and prints its message. Let's run this code and see how it works. And as you see, the output here is this is a custom error. We have completed the lab on exception handling in Python. In this lesson, we handled exceptions using try, except, else, and finally blocks, used the raise statement to trigger exceptions, chained exceptions with raise from to preserve error context, created and handled a custom exception class. These are essential skills for writing robust, error-resistant Python programs. Keep practicing to reinforce your understanding. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson, our first lesson in working with the operating system module. In this lesson, we will explore the OS and sys modules, focusing on environment variables. In this lesson, we aim to learn how to access, modify, and delete environment variables using Python. By the end, you will be comfortable managing these important operating system parameters. So, what are environment variables? Environment variables are key value pairs used by operating system to store settings and configurations. They help programs and scripts determine how to operate within their environment. Examples include path, which defines directories for executable searches, home, the user's home directory, and user, which identifies the current user. Understanding these is crucial for dynamic script behavior. Accessing environment variables in Python is straightforward. Using the OS module, you can retrieve values with os.environ.get method. For example, os.environ.get home will output the user's home directory. If the key doesn't exist, Python returns none, making it safe to handle unknown variables. You can also set custom environment variables within Python. For instance, assigning a key value pair like os.environ myvar equal value will store a variable in the current session. Remember, these changes are limited to the script's runtime and don't persist after the script ends. To delete an environment variable, you use Python's del keyword. For example, del os.environ my_var removes the variable. After deletion, attempts to access it will return none. Note that deleting a variable that doesn't exist will raise an error, so handle this scenario carefully. Environment variables are incredibly versatile. They can store API keys or secret tokens for secure script configuration. They can dynamically adjust path by modifying the path variable to include custom directories. Finally, they allow user-specific settings by referencing variables like home for locating user-specific files. So mastering these applications will make your script dynamic and adaptable. To recap, you can access environment variables using os.environ.get. To set a variable, assign a value to os.environ, and to delete one, use del os.environ. These tools allow you to make your Python scripts flexible and configurable, adapting to a wide range of use cases. Thank you for watching and see you in the next lesson. Hello and welcome to the lab lesson on environment variables. In this hands-on lesson, we will practice accessing, modifying, and deleting environment variables using Python. So let's get started. Our first task is to access an existing environment variable. We will retrieve the value of the home variable, which stores the path to the user's home directory. Let's start typing our code. To deal with environment variable, I will import OS module. Then let's use the print function to retrieve the home environment variable using the environ.get method. So here I will type os.environ.get, then between two parentheses I will type the variable I want to get its value. In our case, it's home. When you run this code, you should see the directory path for your user profile. If you don't, ensure that your environment is correctly set up. Now let's execute this code. So I will use Python 3, then lab_1.py. Now press enter. And as you see, it printed out the value of the home environment, which is /home/Turkey. Let me comment this line. Now let's set a custom environment variable. This is useful for storing temporary configuration details in your script, of course. So let's here use os.environ. Then I want to add a new environment variable. lab_var, and the value for this environment will be Python lab. Now let's access this environment variable using the print function and os.environ.get, and let's add the variable we want to get its value, which is, of course, lab_var. So this should output Python lab to the console. Remember, this variable exists only within the current Python session. To validate our work, I will execute our code. And as you see, I got an error here. Method object is not subscriptable, and that's because I didn't use the right parentheses. So it should be like this. Now let's execute the script again. And as you see, as expected, it printed out Python lab. Okay, now let me comment those lines. Now let's modify an environment variable. So suppose you want to append a new directory to the path variable. Let's see how we can do that. So I will use the environ method. So let's type os.environ. Then I want to append a new value to the path. So let's type path here. And this will equal, or sorry, plus equal, then 2 dots /new/custom/path. Now let's print the path value using print os.environ.get path. So this demonstrates how you can dynamically adjust your system's path during runtime. To validate our work, I will execute the code. And as you see, this is the path values. And here, as you see, we appended a new path, which is /new/custom/path. Now let me comment those lines. Finally, let's delete an environment variable. For example, we will remove the lab_var variable we just created. So let's first uncomment this. So right now we added a new variable to the OS environment. The name of the variable lab_var. And now let's see how we will delete it. So to do so, I will type del os.environ, then the environment variable we want to delete, which is lab_var. After that, let's try to get this variable after the deletion. And also let's get the variable here. Also, let's add here print statement get lab_var value after deletion. Anyway, after running this, the output should be none. So you can remove this print statement if you want. Now let's execute the script. And as you see, first we set a new environment variable, and the first print statement printed out Python lab. Then when we deleted this environment variable, now we get none, indicating that the variable no longer exists. To wrap up, try accessing other environment variables like user or shell on your system. Set a new variable with your name and modify an existing variable. Experiment to reinforce what you have learned. In this lab, we explored environment variables hands-on by accessing, setting, modifying, and deleting these variables. You now have a foundational understanding of their role in making scripts dynamic and configurable. Keep practicing, and I will see you in the next lesson. Hello and welcome to a new lesson on file and directory operations. In this lesson, we will explore file and directory operations using Python, focusing on how to manage them programmatically. In this lesson, our objective is to learn how to manage files and directories using Python. We will cover key functions for checking, creating, modifying, and deleting files and directories. The first operation we will explore is checking the current working directory. The os.getCwd method allows you to retrieve the absolute path of the directory your script is running in. For example, running print os.getCwd will display the current path. This is useful for understanding where your script starts. Next, let's learn how to change the working directory. The os.changeDir method allows you to move to a different directory by specifying the target path. For example, using os.chdir, then the path to directory changes the working directory. To confirm the change, you can print the current directory again using os.getCwd. To see the contents of a directory, we use the os.listDir method. This method returns a list of files and subdirectories in the specified path. For example, calling os.listDir will list the files and directories in the current working directory. This is useful for exploring what's available in a directory. Creating directories can be done in two ways. The os.makeDir function creates a single directory, while the os.makeDirs function creates nested directories in one step. For example, os.makeDir new dir creates a single folder name new_dir, and os.makeDirs nested/dir/structure creates a nested directory structure. Make sure the directories don't already exist when using these methods. Deleting files and directories is straightforward but requires caution. To delete a file, use the os.remove function, as in os.remove file.txt. For directories, use os.rmdir to delete an empty folder. For example, os.rmdir dir_name. Remember, directories must be empty to be removed. If they aren't, you will need additional steps to clear their contents. These operations are valuable in real-world scenarios. For example, you can automate file management tasks like organizing or cleaning up files. You can also set up directory structures for new projects or scripts. Additionally, combining these methods with error handling allows you to gracefully handle missing or inaccessible files and directories. Let's summarize what we have covered. To check the current directory, use os.getCwd. To change directories, use os.chdir. To list files and directories, use os.listdir. For creating directories, use os.mkdir or os.makeDirs. To delete files, use os.remove, and for empty directories, use os.rmdir. These methods provide you with a complete toolkit to manage files and directories programmatically. With this knowledge, you are now ready to manage files and directory efficiently in your Python project. Thank you for watching, and see you in the next lesson. Hello and welcome to our lab lesson on file and directory operations. In this hands-on lesson, we will practice working with files and directories programmatically using Python. By the end, you will be comfortable navigating directories, creating and deleting files, and setting up directory structures dynamically. Let's begin by checking the current working directory. This tells us where our script is running. So let's first import the OS module. Then we will use the print function, and we will use the getCwd method from os module. When you execute this, it will display the absolute path of your current directory. This step is essential for ensuring you are in the correct location before performing any file operations. Now from the terminal, let's use Python 3 to execute our lab2 file. And as you see, the output is the absolute path for our current working directory. Now let me comment this line here. Now let's change the current directory. To do this, we will use the os.chdir function. So here I will do os.chdir. Then let's say that I want to change the directory to /temp directory. Now let's get the current working directory using the print function and the getCwd function. So this changes the working directory to the specified path and then confirms the change by printing the new directory. Make sure that the target directory exists or Python will raise an error. Let's execute our code, and as you see, first it changed the directory to /temp, then it printed the current working directory, which confirms that we changed directory to /temp. Now let's comment line 4 and line 5. And next we will list the files and directories in the current location using the os.listdir method. So let's print os.listdir. And because we want to list the files and directories in the current location, so I will add dot here. So this lists all file and directories in the specified path. Parsing dot will list items in the current directory. Let's save the file and let's execute the script. And of course, it lists all the files and directories in a Python list. Now let's move on to creating directories. First, let's create a single directory using os.mkdir. So let's type os.mkdir. Then I want to create a new directory. In the current directory, the new directory name is new_dir. Now, if you want to create a nested directory structure, use os.make_dirs. So let's also create a nested directory structures. So here I will do os.make_dirs, then the nested directories. So nested dir structure. When you execute this code, you will see the directories created in your file system. Remember, directories must not already exist, otherwise Python will raise an error. And of course, from the previous lessons, we learned together how to handle the errors. So first, let's confirm that we don't have the new dir or the nested directory structure. So I will execute ls. And as you can see here, I don't have new dir and I don't have the nested directory. Now let's execute our code, and there is no error. It means that the code has been executed successfully. Now let's ls and enter. And as you can see, we have the new dir, which is a single directory, and we have the nested directory. And we can also confirm that inside the nested directory, we have created the dir directory, and under that directory, we have created the structure directory. Let me comment those lines. Finally, let's delete files and directories. To delete a file, we will use os.remove. So let's first create file.txt using the touch command. And from the Python code, I will use the os.remove function to delete the file.txt file. So here let's type os remove, then provide the file name, which is file.txt. Let's confirm that the file has been created. So here is the file. Now let's execute our code. And let's confirm that file.txt has been deleted. And as you can see, we don't see file.txt anymore. Now let's see how we can delete an empty directory using os.rm dir. To do so, I will type os.rm dir. Then let's delete the directory we created before, which is new_dir. Note that directories must be empty to use os.rm dir function. If they are not, you will need to remove their contents first or use additional methods for recursive deletion. Now let's execute our code and let's verify that new_dir directory has been deleted by executing ls command. And as you can see from the output, we don't see the new_dir anymore. In this lab, you have seen how to dynamically create and manage files and directories. These skills are essential for tasks like automating directory setups for projects, cleaning up necessary files, or organizing data dynamically. With this hands-on practice, you are now equipped to handle file and directory operations programmatically in Python. Experiment further by combining these operations to create and manage complex directory structures or automate routine tasks. Thank you for watching and see you in the next lesson. Hello and welcome to a new lesson. In this lesson, we will explore system-specific parameters and functions using Python's sys module. This is an essential part of building adaptable and dynamic scripts. In this lesson, our objective is to understand and utilize the sys module for system-specific operations. By the end, you will know how to handle command line arguments, exit programs, and retrieve interpreter details programmatically. Let's start with command line arguments. The sys.argv list allows you to access arguments passed to a script. For example, the first element, sys.argv0, is the script name, while sys.argv1 2 dots contains additional arguments. This is useful for scripts that need input at runtime. Running the code, print sys.argv will display all the arguments as a list. Next, let's talk about exiting programs. The sys.exit function allows you to terminate a script gracefully. You can pass an optional status code where 0 indicates successful execution and non-zero values represent errors or custom codes. For example, using sys.exit0 will end the script and signal that everything executed successfully. This is particularly helpful for managing conditions or errors. Now let's look at retrieving Python interpreter details. The sys.version attribute provides the version of the Python interpreter, and sys.platform tells you the operating system the script is running on. For example, running print sys.version will show the Python version, and print sys.platform will identify the operating system. This is useful for debugging and ensuring compatibility across environments. Here are some practical applications for the sys module. Use command line arguments for dynamic input, allowing your scripts to be more flexible. Manage script execution with sys.exit to handle conditions cleanly. Finally, use sys.version and sys.platform to debug and ensure compatibility, especially when working in diverse environments. Let's summarize. To access command line arguments, use sys.argv. To exit program, use sys.exit with the status code. For Python interpreter details, use sys.version for the version and sys.platform for the operating system. With these tools, you can make your Python scripts more dynamic and adaptable to various environments. That's all for this lesson on Sys module. You are now equipped to use these system-specific tools in your Python projects. Thank you for watching and see you in the next lesson.